Hello, space enthusiasts. Today, we have an incredible lineup of stories from across the cosmos, from groundbreaking developments in lunar exploration to fascinating discoveries about our own galactic neighborhood. We're covering the full spectrum of space news. We'll look at Japan's latest challenges in rocket development, check in on NASA's Europa Clipper as it makes its way toward Jupiter's icy moon, and explore some remarkable findings about what makes our Milky Way galaxy unique. We'll also get updates on SpaceX's busy launch schedule and hear about an exciting lunar mission that's about to take flight. Stay with me as we journey through these astronomical developments and uncover the latest adventures in space exploration. Japan's space agency, JAXA, encountered a significant setback on Tuesday this week during a crucial engine test of their Epsilon S rocket. The test, conducted at the Tanegashima Space Center in southwestern Japan, was abruptly terminated when a fire broke out at the test site, just 49 seconds after ignition. While fortunately, there were no injuries reported and the external facility remained undamaged, this failure could push back the rocket's debut launch beyond its targeted March deadline. The incident is particularly concerning as it follows previous setbacks, including another engine test failure in July last year due to thermal damage to its ignition systems. The Epsilon S rocket, developed in partnership with IHI Aerospace, represents a crucial component of Japan's space ambitions. It's designed to be the next generation in their solid-fuel small rocket series, aimed at making Japan more competitive in the growing commercial space launch market. This setback is especially significant given the broader context of Japan's space program development. While their larger H3 rocket has recently achieved success with 3 consecutive flights this year after initial difficulties, the Epsilon S problems highlight the ongoing challenges in developing reliable space launch systems. The Japanese government has emphasized that rocket development remains extremely important for maintaining the autonomy of their space program. As JAXA and IHI conduct their investigation into the cause of this latest incident, they'll need to implement thorough countermeasures before proceeding with any further tests. This careful approach, while necessary for safety and reliability, means additional delays for Japan's space missions and satellite launch plans. An update now from way out there, so to speak. NASA's Europa Clipper spacecraft is making remarkable progress on its journey to Jupiter's moon Europa, having already covered an impressive 13 million miles since its October launch. The spacecraft, traveling at a breathtaking speed of 22 miles per second relative to the Sun, has successfully completed several critical deployment milestones that will be essential for its future mission to investigate Europa's potential for supporting life. The mission team has been particularly focused on deploying and testing the spacecraft's crucial scientific instruments. One of the first major achievements was the successful deployment of the spacecraft's massive solar arrays, which stretched to the length of a basketball court. This was followed by the extension of the magnetometer boom, reaching out 28 feet from the spacecraft. The team has confirmed that all 3 sensors on the magnetometer are functioning perfectly, ready for their future task of measuring Europa's magnetic field to help determine the depth and salinity of its subsurface ocean. Another significant milestone was the deployment of the spacecraft's radar antennas. These impressive structures extend nearly 58 feet from the spacecraft, complemented by 8 smaller 9-foot antennas. This sophisticated radar system will be instrumental in peering beneath Europa's icy surface, providing unprecedented insights into what lies below. The mission team is now conducting thorough health checks on 7 additional instruments, which will continue through the coming months. Some instruments, particularly the visible imagers and spectrometers, are keeping their protective covers closed for now, shielding them from potential solar damage as the spacecraft traverses the inner solar system. Looking ahead, the spacecraft is preparing for its first major navigational milestone, a gravity assist maneuver at Mars in March 2025. This clever use of planetary gravity will help adjust the spacecraft's trajectory and increase its speed on its long journey to Jupiter, where it will arrive in 2030 to begin its extensive study of Europa's potential for harboring life. SpaceX has been maintaining an impressive pace of launches, with several significant missions marking important milestones for the company. Their Falcon 9 rocket just achieved its 400th orbital mission, setting a new record for the fastest booster turnaround time at just 13 days and 12 hours, beating their previous record of 21 days. The company has a busy schedule ahead with 4 Falcon 9 missions planned from all 3 of their active launch sites in the United States. These launches include multiple Starlink satellite deployments, continuing to expand their global internet constellation, which now numbers over 7,400 satellites in orbit. In particularly exciting news, NASA has selected SpaceX's powerful Falcon Heavy rocket to launch the ambitious Dragonfly mission to Saturn's moon Titan in 2028. This $3.35 billion mission will send a car-sized rotorcraft to explore Titan's unique environment, which features lakes and seas of liquid hydrocarbons, making it the only celestial body besides Earth known to have stable surface liquids. The Dragonfly launch contract, valued at approximately $257 million, adds to SpaceX's growing portfolio of high-profile NASA science missions. The Falcon Heavy has already successfully launched NASA's Psyche asteroid probe and the Europa Clipper spacecraft. After its launch in July 2028, Dragonfly will spend 6 years traveling to Titan, where it will investigate the moon's potential to support life and study its intriguing prebiotic chemistry. The Falcon Heavy continues to prove itself as a reliable vehicle for NASA's most ambitious missions, currently standing as the second most powerful operational rocket after NASA's Space Launch System. With 11 successful launches under its belt, including the recent Europa Clipper mission, SpaceX's heavy lift vehicle has become a cornerstone for complex deep space exploration missions. Next, exciting developments are taking shape in the commercial lunar exploration sector, with Firefly Aerospace announcing a major milestone for their Blue Ghost lunar lander. The spacecraft has successfully completed its rigorous environmental testing phase, clearing the way for its upcoming mission to the moon as part of NASA's Commercial Lunar Payload Services initiative. The testing, which wrapped up at NASA's Jet Propulsion Laboratory, put the lander through its paces in conditions designed to simulate both the journey through space and operations on the lunar surface. Using a specialized thermal vacuum chamber equipped with solar simulation capabilities, engineers subjected Blue Ghost to the extreme temperature variations it will face during its mission. The lander also passed crucial tests for vibration resistance, acoustic performance, and electromagnetic compatibility. The successful completion of these tests has paved the way for the next phase of the mission. Blue Ghost is now scheduled to make its way to Cape Canaveral in mid-December, where it will be prepared for launch aboard a SpaceX Falcon 9 rocket. The launch window opens in mid-January 2025, giving the team a 6-day opportunity to begin this ambitious lunar journey. Once launched, Blue Ghost will embark on a 45-day journey to the moon, during which time the mission team will conduct comprehensive system checks and prepare the scientific payloads. The landing site is set for Mare Crisium, where the spacecraft will operate for a full lunar day, equivalent to 14 Earth days. During this time, it will carry out various scientific experiments, including subsurface drilling, sample collection, and studies of lunar dust behavior. The mission, dubbed Ghost Riders in the Sky, represents a significant step forward in commercial lunar exploration and marks the first of 3 planned Firefly missions supporting NASA's broader Artemis campaign. This approximately 60-day mission will be managed from Firefly's Mission Operations Center in Cedar Park, Texas, helping to establish the foundation for a sustainable commercial presence on the moon. Our understanding of the Milky Way has taken an interesting turn, thanks to new research comparing our galaxy to 101 of its cosmic cousins. While astronomers have long used our galaxy as a standard template for understanding galactic formation and evolution, it turns out the Milky Way might be more of an outlier than we previously thought. The findings come from the SAGA survey, which has been meticulously studying galaxies similar in mass to our own. One of the key differences they've discovered relates to our galaxy's satellite systems. While the Milky Way has relatively few satellite galaxies actively forming stars, mainly just the Large and Small Magellanic Clouds, other similar galaxies typically show much more active star formation in their satellite systems. The research also revealed that about a third of the studied galaxies have large satellite companions similar to our Large Magellanic Cloud, and these systems tend to have more satellites overall than our Milky Way. This suggests our galaxy's satellite system configuration is somewhat unusual compared to its peers. What makes this particularly intriguing is how it affects our understanding of galaxy formation and evolution. The Milky Way has long served as our primary laboratory for studying these processes. But if it's not as typical as we thought, we may need to readjust some of our theories and models. The findings also raise fascinating questions about dark matter's role in galaxy formation. Since galaxies form within massive dark matter halos, these differences between the Milky Way and its counterparts might hint at variations in how dark matter shapes galaxy evolution. This could have significant implications for our understanding of the universe's structure and development. Well, that's all for today's episode of Astronomy Daily. I want to thank you for joining me on this journey through the latest developments in space exploration and astronomical discoveries. If you'd like to stay up to date with all the latest space and astronomy news, please visit our website at astronomydaily.io. There you'll find our constantly updating newsfeed, and you can sign up for our free daily newsletter. You can also catch up on all our previous episodes right there on the website. And don't forget to join our growing community on social media. You'll find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. This is Anna, reminding you that the universe is full of wonders. And we'll be back tomorrow with more fascinating stories from the cosmos. Until then, keep looking up.